Quadratic functions, vertex form. We've looked at ax squared plus q so far. For example, like 2x squared plus 5. And that's taught us some things about what does this number do. So what does the number do in front of the x squared, and then what does that number do? And so the role of a, so far we've seen that a determines if the quadratic opens up. That would be if a is greater than 0. So 2, 3, 1, a half. And a can also determine if the quadratic opens down. If a is less than 0. And then depending on how large a is, so the larger a is, the faster it moves. So we usually do something like, how do I write that? So if a is larger than 1, then it opens faster. And that's true actually if a is like less than a negative 1 as well. So we often do this, the absolute value of a greater than 1, then we know that it goes faster than the traditional x squared. Okay, q, on the other hand, q is this one, and just like in linear functions, if that's at 2x plus 5, if it's written this way, that is the y-intercept still. Okay? Well, there's another way of writing parabolas, and that's called the vertex form. And so the vertex form is right here. And if something is given to you in the vertex form, then the vertex of the parabola is actually known to us. Now, the vertex is either the lowest or the highest point on the graph. So I'm just actually going to just graph this thing, and then we'll see where we are. So it's a parabola. So I need more than 2 points. So let's start with 0 and see what happens. So we get 2 times a negative 1 squared minus 4. So that's 1. 2 times 1 is 2. 2 minus 4 is a negative 2. And let's see what happens at 1. 2 times 1 minus 1 is 0. And 0 squared is 0. So that's 0. So that's a negative 4. And at 2, I get 2 times 2 minus 1 is 1, and 1 squared is 1 again, and 2 minus 4 is a negative 2. So notice I get the same value here. This over here, 1, negative 4, that's actually going to be our vertex. And if you look at the equation, and the way that it's given to you here, the vertex is going to be the letter h and k. So h is, if this is x minus, then h is just the number. So h here is just 1. So h is 1 in ours. And then k is that one. So k is a negative 4. So at 1, negative 4, I'll get my lowest point. So let's graph that one. 1, 1, 2, 3. That is the lowest point on my graph. And then you get negative 2 here and a negative 2 there, and that has everything to do with symmetry, the fact that parabolas are always symmetric. So then I need one more point, so let's just use 2, and if 3. If I use 3, I'll get 3 minus 1, it's 2, 2 squared is 4, 4 times 2 is 8, and 8 minus 4 is 4. So at 2, I was at 4, so 1, 2, 3, 4. That means if you go over 1 this way, you need to be just as high on this side. So at a negative 1, you should also get 4. And that gives me enough information to graph this parabola. Generally speaking, we want to graph parabola so that we can see the lowest point. So we want to have the lowest point visible. And we want to see where it crosses the x-axis. So x-axis, we want to be able to at least sort of see what the x-intercepts are. Now, in this case, we know it's between 2 and 3 over here, and between 0 and a negative 1 over there. We don't really know what it is, but, that's good enough. Okay, so what would happen if we change some of the values in the function equation? So some of the values would be, that we're going to look at is, so what happens if we change this to, What happens if we change this minus 1 to like a plus 1 or a minus 4? What happens if we change this negative 4 to like a positive 4? Okay? Well, let's look at it. So a still has the same role. So a, if you change it, so if you make it, for example, f of x is equal to a negative 2 and then x minus 1 squared minus 4, then now instead of it opening up, it will open down. So that has not changed. The role of a is exactly the same as we saw earlier, which is that if a is larger than 0, it opens up. If a is less than 0, that looks like a cube, doesn't it? That's supposed to be an a. So if a is less than 0, it will open down. And the larger the magnitude of a, the faster it moves. So this is supposed to be an a less than 0. Okay, so that's not going to change. The role of h, if you change h, and then I don't think I gave myself enough room. Hopefully I gave you guys a little more room. If you change h, then that moves your vertex coordinate. Let's see, which one of these was that? H was this one, right? And h represented a movement this way. So if I'm looking at this, then h will move it left or right. So the role of h is it moves the vertex either left or right. Okay, what I mean with that is moves left or right. This is all relative to, comparing it to what does x squared look like. So keep in mind that x squared looks a little like this. It goes through 0, 0, 1, 1, and negative 1, 1. And so we're comparing it to that. So if you change h, then you will change where the vertex is from left to right. So let's look at another example of this. So what if I still have f of x is 2, and now if I said x plus 3 squared minus 4. Now if you want to know which way it moves, keep in mind that normally in the x squared, the vertex is at 0, 0. And so the lowest point there is at 0, 0. So you want to know, relative to that, what does x plus 3 do? So in essence, what you're looking at is, well, x plus 3 equals, you want that to be 0. That's sort of where this parabola centers. So that actually makes it go to a negative 3. So if you have a plus 3 here, then it actually moves left. So it's backwards from what you would think. Okay, k, on the other hand, does exactly what you think it does. Okay, k moves it up or down. So in our example we had minus 4, but if I change this to an f of x is equal to 2, and then it was x minus 1 squared, if I make this a plus 2, then that is up 2 units for the vertex. Up 2 units. Units is with an n. So the vertex goes up 2 units. Okay, what is the domain of, and then we have that in vertex form? Well, it's still a quadratic, so let's see, can you plug in any value you want? Can you plug in any x and get a y value? Well, yes, you can square any number, so the domain for the quadratic is still going to be all real numbers. How about the range? Well, the range is going to depend on the vertex. Okay, this one depends on the vertex. And it also depends on the value of a. So if I'm looking at the picture that we saw that I created over here, and I want to know the range for this parabola, this is the lowest point. So the domain was all real numbers. But the range is asking me for what y values do you get. Well, at some point I get a negative 4. But if I go to the right, it always goes up, and if I go to the left, the graph is always also going up, so the range is a negative 4 to infinity. So the two things that influence that are, where is your vertex? So it used to be at 0, 0, it was moved down 4. So instead of the range going maybe from 0 to infinity, now it goes from a negative 4 to infinity. And the other role, or the other thing that influences that is A. Because if I made A negative, if I graph this and I said, well, you know what, I'm just going to write it as a negative 2 x minus 1 squared minus 4. You would still get your vertex here, because look, h and k did not change, so it still would be a vertex at 1, negative 4. But the negative 2 is going to flip this thing, so instead of it going up 2 and over 1, it's going to go down 2 and over 1, and the same thing over here. So on the blue parabola, and I missed this one rather badly, let's do that one again. So on the parabola that I'm sort of dotting in blue, here the domain is still all real numbers, but now the range for that one would be from a negative infinity, and then it gets to be a negative 4, but that's it, it never goes above it. Okay, what else did we have in this line? So what are the intercepts? Okay, so let's look at the intercepts. So let's see if we can find the intercepts for x minus 1 squared plus 2. Well, you just plug in zeros. So if you do that for x, that's actually fairly straightforward. We get 2 times 0 minus 1 squared plus 2. So we already did this, but that's 1, and 1 times 2 is 2, so that's 4. So 0, 4 is your y-intercept. Okay, that's not very difficult. If you plug in y as 0, you have to actually solve for it. So you subtract 2 on both sides. That's not what we were working with, right? Nope, this is a different one. This was a negative 4 for us. Does that impact it? Yeah, it does. Well, let's solve this anyway, and then we'll do the other one. So x minus 1 squared, we still have a 2 here, and then we divide by 2, I get a negative 1 is x minus 1 squared, and then you take the square root, so it would be plus or minus the square root of a negative 1. And that should give you something to think about, because now I have imaginary x-intercepts, and that's not what we want. Well, I mean, it's okay if we had it, but that means that this quadratic, which would have had a vertex at 1, 2, 1 and 2, and since it always goes up, it will look like this, so it does not have x-intercepts. Okay, well, let's erase that. I'm sorry if you can't do this, but that's okay. What I needed to do, apparently, was use the function that we've been working with, which was 2 times x minus 1 squared minus 4. Okay, so plug in 0. We get 2 times 0 minus 1 squared minus 4. So 2 minus 4 is a negative 2. So 0, negative 2 is your y-intercept. And then I need to do 0 equals 2 times x minus 1 squared minus 4. Solve for this one. I do add 4 on both sides. Divide by 2. I get 2 equals x minus 1 squared. Take the square root on both sides, and now you see you do have a positive square root here. So this one does have x-intercepts. I need to add 1 on both sides. So the x-intercepts occur at 1 plus or minus the square root of 2. So the square root of 2 is like 1.4. So it's 1 plus 1.4-ish. This is about 2.4. Or 1 minus 1.4, which is negative 0.4. So is that consistent with the graph that we had? Do we have one intercept just past 2 and one just between 0 and negative 1? So yeah, I mean, my graph wasn't great, but 2 was here, and so I have it to the right of 2 and to the left of 0. So that's pretty good. Okay. So last part, graphing and finding intercepts. So if it's given to you in this format, take a quick look at all this, and the only thing I would suggest here is you can rewrite this one, put a -1 there, and then you can start from there. So I would find the vertex first. It's in vertex form, so the vertex is h and k, with h being here, h here is 2, and k here is 5. Okay, if that's a -2, h is at 2. So the vertex is at 2, 5. Why is that important? Well, that's the middle of the table. And then you just use one number here, one number here, and one number here, and one more over there. So with 5 points you can generally graph a parabola, especially if one of them is the vertex. And then just fill it in. So we get a -1 times 3 minus 2 is 1, 1 squared is 1, so -1 plus 5 is equal to 4. Then symmetry tells you that on this side you should also get 4. 0 is easy to plug in, so let's use 0 over here. So -1 times 0 minus 2 squared, so that's a -2, that's 4, that's a -4 plus 5 is a -1, so that means you get a -1 over here. Again, that has to do with symmetry. And then we can graph it. So, let's see, I have 5 is the largest, and then after that this thing goes down, right? So let's graph it this way. And so I have 1, 2, 1, 2, 3, 4, 5. There's my vertex. And then at 3 I got 4. It means that at 2 I got 4. At 0 I had, I guess a -4 plus 5 is a positive one, right? Just got that over here. Sorry. So then this one is a positive one as well. So at 0 I should get 1, and that means at 4 I should get 1. Okay, you can see that the intercepts occur just to the right of 5 and to the left of 0. But it says that we have to actually find them, so I'm going to find the intercepts. So I'll need to move this just a little bit. So let's see. Well, one intercept I already have, right? 0, 1. So the y-intercept is at 1, because it's right here. So the one that I need to solve for is this one, a -x minus 2 squared plus 5. Move the 5, so it's a -5. It's a -x minus 2 squared. Cancel the negatives, take the square root, make sure you use a plus or minus. So this is actually completing the square. For those of you that are sort of wondering, is that completing the square? Yes, we're completing the square. So 2 plus or minus the square root of 5 is where your x-intercepts are. The square root of 5 is just past 2, so because the square root of 4 is 2, so if you do 2 minus 2, you are just to the left of 0, so that one's pretty good. And you should be just to the right of 5, and my line is not very good over on this side. So we'll cheat a little. Now it's just the right 5. Alright, one more. Graph and find the intercepts 4, x plus 4 squared minus 2. So same thing, I would identify h first. Keep in mind that if that's a plus 4, it's a minus 4. K is a -2. So that means that the vertex is at a -4, -2. So when I make my table, I'm going to plug a -4 right there, and a -2 there. That means I need to plug in, like, what happens at a -3, and a -5, and then maybe at a -2, and then a -6. So at a -3, you get a -3 plus 4 squared. So that's 1, and 1 minus 2 is a -1. So I should get a -1 here as well. And then at a -2, -2 plus 4, that's a -2, and -2 squared. I'm sorry, -2 plus 4 is +2, and a +2 squared is 4, and 4 minus 2 is 2, so at a -6 I should also get 2. Graphing that, I get most of the negatives, don't I? So 1, 2, 3, 4, 5, 6. 1, 2, 3, and then we'll go to this side. So where are we? -4, -2. So 1, 2, 3, 4, -4, -2. I'm a -1 here, and I'm a -1 there, and then I'm at a +2 if I go one more, and if I go one more this way. Finally, quadratic that looks the way it's supposed to, more or less. Okay, solving for the intercepts. So I don't have either one of them yet. So if I make x is 0, I get 0 plus 4 squared minus 2. 16 minus 2 is 14. So that's why we don't see it. It's way up there. My graph isn't big enough for that. And then solving for the other one, we would put the 0 over here. X plus 4 squared minus 2. Let's add 2 on both sides. So I get x plus 4 squared. Take the square root, plus or minus the square root of 2 gets rid of the square. So that means my x-intercepts occur at -4. Keep in mind you're going to subtract there. That's a -4, that's an x, plus or minus the square root of 2. Square root of 2 is like, again, it's about 1.4ish, I think. So we are definitely not past 0 yet, and which is clear here. We're definitely in the negatives, definitely in the negatives. Thanks.